I think so. I hope so. I know. All right, go to the next page. We're going to do an example with this. It says, Mike is an avid golfer who would like to improve his play. A friend suggests getting new clubs and lets Mike try out his 7-iron. Based on years of experience, Mike has established that the mean distance that a ball travels when hit with the 7-iron, with his old 7-iron, is mu equals 175 yards with a standard deviation of sigma equals 15 yards. He is hoping that this new club will make his shots with a 7-iron more consistent, which means less variable. And he goes to the driving range and hits 50 shots with the new 7-iron. So let me ask you this. We've got means, we've got standard deviations. What number are we really concerned about in this test? What's he interested in? Okay, the difference between the two clubs. So we've got what his old club does, right? So we're going to gather some information on the new club. But what information are we going to look at? Are we going to look at the distance it's shot, or are we going to look at the standard deviation of those shots? What do you think, Jarrett?
The standard deviation.
Why?
Because he said he wants more variability, less variable.
Yeah, he wants the numbers, the distances that he shoots to be less variable. So his parameter of interest is actually going to be, what is the standard deviation of, what is the variability? Does that make sense? If he had asked which one shoots it farther, then we'd be looking at the mean, like what's the average distances we could shoot. Does that make sense? Okay. So when we answer this, we would say the parameter of interest in this setting is the standard deviation of the distance the new 7-iron, I should say the distances, the new 7-iron can drive a ball. The other option here in this test would be the mean of the distances, but that would be if he was concerned about how far he was able to hit it. But he's concerned about variability, so our parameter of interest is the standard deviation of the distances that the new 7-iron can drive a ball. Appropriate hypotheses here would be the null hypothesis is sigma, remember it's a parameter from our population, is equal to 15 yards. That's what was given to us. That's our claim. Now, if the new ones are different, perhaps our alternative hypothesis, he's hoping it's going to be less variable, so we say we hope for less than 15 yards for this sigma. So we're matching up our null hypothesis is what is either currently happening or claimed to be happening. And then our alternative is sort of what we assume is probably going to happen. He wants to see if we're less variable with this new 7-iron. So he wants the standard deviation to be smaller. All right, I want you to take a minute and go to page 532 and answer the questions at the bottom of the page. It says, for each of the following settings, A, describe the parameter of interest. B, state the appropriate hypotheses. Okay, so on page 532, the first one says, according to the website, sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep at night. That's like our claim. That's what's happening right now, we think, right? But Janie wonders whether this result holds true in her large high school. She asks a simple random sample of 100 students at the school how much sleep they get on a typical night. So now you're thinking, well, are we talking about the numerical data? But then what she says is, in all, or what it says, 75 of the responders said less than 8 hours. So now they're going to compare it to groups or categorical data. We're going to say, do they fit in the less than 8, or are they not in the less than 8? So as soon as it's categorical data, it's a proportion. Okay? And so number one, P equals, our parameter of interest, is the proportion of students at Janie's school, Janie, who get less than 8 hours of sleep per night. But the key is it's a proportion. Okay? And for right now, if that's all you can get is that it's a proportion that's good enough, and we're going to build on it, okay? And then for part 2, it says, that's for part A, sorry. For part B, they want you to write down what your null and alternative hypothesis would be. And so this is where we say H naught, colon, P equals 0.85. That would be if what's happening in her school is the same as what's claimed in the entire larger population. And then H alternative is that, let's see what she said. She wonders if this result holds true. She asks, so she's basically just wants to know if it holds true for her school. She doesn't have any assumption ahead of time that it's less or that it's more. She just wants to know if her school is different. And so the wording or the notation is not equal to 0.85. If that statement had said, Janie wonders if the kids at her school get less sleep, then we would use a less than symbol. Janie thinks the kids in her school get more sleep, or something, not more sleep, because that's the wrong way to word it, but Janie thinks a smaller proportion of students get 8 hours, then we would say less than.
So HA isn't based on the data?
No, H alternative is still not based on the data. It's based on the way that the statement is made. Does that make sense? Okay, step number 2, situation number 2. As part of its 2010 census marketing campaign, the U.S. Census Bureau advertised 10 questions, 10 minutes, that's all it takes. On the census form itself, we read, quote, the U.S. Census Bureau estimates that for the average household, this form will take about 10 minutes to complete, including the time for reviewing the instructions and answers, unquote. We suspect that the actual time it takes to complete the form may be longer than advertised. So that's our alternative, right? That's what we suspect. But when we jump in and do our hypothesis, so let's answer the first question though. What is the parameter? Are we looking at proportions? Are we looking at means? Are we looking at something different than that? Mean. It's an average time that it takes to complete the form. And so average means mean. So we're looking at, for part A, mu equals the mean number of minutes to complete the form. And then our null hypothesis is that mu equals 10, because that's 10 minutes if we want units with it. And then the alternative hypothesis, they think it's going to actually take longer. So that's what our test will be. What's the chance, or what's our probability that against the claim and in the direction of being longer? Okay, because writing the hypothesis is like the most important, not most important, but I mean if you do it wrong, you get everything else wrong. What I had is I handed out a paper that has some extra examples. We're going to stop here with the notes, and we're going to have a homework assignment that goes only through writing hypotheses. But before I tell you what that homework assignment is, I want to look at those examples that I handed out. See if I can find, where'd my paper go? Still working? I pulled a bunch of these from the internet, so I'm going to actually go to example 3 first, because the other ones have all the answers typed out on it, so you don't need me to explain them, but I will be if we have time. Okay, example 3 says, a recent survey of college campuses across Ontario that, oh yeah, did you get one of those? Yep. Claims that students spend an average of 2.7 hours a day using their cell phones. A random sample of 35 Durham College students shows an average use of 2.9 hours a day, with a standard deviation of 0.4 hours. Do Durham College students use their cell phones more than the typical Ontario college student? Don't make the mistake of saying, well, obviously 2.9 versus 2.7. because this was just a sample, right? So our possible conclusions are either they are different or they might not be different. It just was because of chance that we got a weird sample. Okay? So our hypotheses, though, is really what we're concerned about. And whenever we write our hypotheses, we need to describe the parameter that we're using. So H naught and H alternative are about what parameter? What's the parameter we're interested in words? Okay, how long they spend on average on their cell phone. So what kind of parameter are we using? What is average? Mean, the mean. So mu equals the mean number of hours students spend on phone. I want you to get in the habit of reading through examples and being able to do this. And then our null and alternative are, the null is a statement of what, sort of like the claim, or what's supposed to be happening. And so what is mu, according to this, a recent survey of college campuses all across Ontario? That must be the more accurate claim number, right? The 2.7. And so mu equals 2.7 hours is our claim. Our alternative, though, when we start to look at Durham College students, we wonder, do the students at this college use their cell phones more? Because that's our question. And so we're going to say more than 2.7 hours. So our test will be a statement of one-sided test. Do we use more than what was claimed? Okay, flip back to the other side. These ones are all typed out for you. They're in like a little bit more because I pulled these from an internet site. So the first one, it's called a one sample of one categorical variable. So categorical variables are like, okay, percent of students that do something, so proportions. It says about 10% of the human population is left-handed. Suppose a researcher at Penn State speculates that students in the College of Arts and Architecture are more likely to be left-handed than people found in the general population. We only have one sample since we will be comparing a population proportion based on a sample value to a known population value. The research question, basically, are artists more likely to be left-handed? It's a good question. The response variable, what they're looking at is whether people are right-handed or left-handed. But this is what's important to me. Can you state the null and alternative hypothesis? The null hypothesis is that P equals 0.10. 10% of the population is left-handed. That's the claim. But notice I used P because it's a proportion. You guys look bored, but I don't know if you're getting it or you're bored. Abby? Okay. Yep, there's a lot of, and that's why I wanted to do a bunch of different examples. Hopefully it helps. But so then this one is, what's my alternative going to be? If we're curious about this question, we want to know, are artists more likely to be left-handed than the general population? Greater than 0.10. So I've got, here's the null, here's the alternative. They typed it out in words for you too. So like if you're confused, you go back and read these later. Okay, a generic brand of an antihistamine, I'm not going to try to say this word, markets a capsule that is 50 milligram dose. The manufacturer is worried that the machine that fills the capsules has come out of calibration and is no longer creating capsules with the appropriate dosage. So the research question is this: does the data suggest that the population mean dosage of this brand is different than 50 milligrams? And so our null, H naught, mu or P? Mu. The mean is equal to 50 milligrams. Or H alternative, mu is not equal to 50 milligrams. Because they only said it came out of calibration. They didn't say if it was less or more. And so it's just a statement of difference. Got it? Okay. Your homework on the learning guide says a whole bunch of stuff for lesson 9.1. We're going to be stopping at number 11, I believe. Nope, not even that far, sorry. Don't go past number 10. So I assigned 1 through 15 odd, so go 1 through 9 odd. Okay, so your day 1 homework. And it's just practicing writing the hypothesis statements.